The family of quadratic functions are the ones that we've just been dealing with. We've been solving, we've been using them to model area, we've been using them to model projectile motion. We did all of the factoring, we did the quadratic formula. So those are our guys that have the x squared. So we have y equals ax squared plus bx plus c. So that is what your equation is going to look like if you're dealing with a quadratic equation. And it might be things like y equals 2x squared plus 5x minus 3. So when you see an equation that looks like ax squared plus bx plus c, that's telling you it's in the family of quadratic functions. And when we talked about projectile motion, and I do apologize because you guys really are getting the Cliff's Notes, or the Spark Notes, I think is what y'all call them now. You're getting the shortened version of this. It's because we are losing days by e-learning, and also I know that this is hard to do at home and to do by yourself. So a lot of these videos you're going to need to watch more than one time. Email me questions, ask me questions. I really wish more people would come when I set up those Google Meets before the quiz. So hopefully you can take advantage of those. If you can't make that time because of whatever, you just can't use that time, email me, let me know, because we could set up something different. I'm happy to help you out because I do know that this is hard for you to do at home by yourself. I do get that. Getting back to the point and off my momism there, sorry about that. Quadratic functions, this is our generic form, and they're graphs. So that's how I got distracted the first time. Their graphs are parabolas, and I did a short set of notes for you on the day we did projectile motion to give you some attributes of quadratic graphs, what their graphs look like. So they're parabolas, which really just kind of look like a right side up U, or in our projectile motion questions, we were interested in this version of a quadratic, the upside down U. So they're always going to look like a right side up U or an upside down U. That's what a parabola is. And the way you can tell if it's going to face up or face down, if A is positive, and by A, I mean this number out in front of the x squared term. If that A is positive, then it's going to face up. If A is negative, it faces down. So if you have -2 out in front, you know that, or -7, doesn't matter. If you know you've got a negative out in front of your x squared term in your function, it's going to face down. So right side up U, upside down U, that's a quadratic function. If it's got x squared, it's a quadratic function. So how can we tell from a table that it's a quadratic function? Well, what you're going to want to look for when you're doing this, your x's are going to be counting hopefully by some constant value, ideally by 1. So these are going up by 1, meaning we're just going left to right across the x-axis. But our y values, you're going to notice they started at 4, got smaller, and then they started to get bigger again. So you'll see that they started large, got smaller, and then got bigger again. You'll also notice that these values repeat. It's symmetric. You're going to find, in this particular case, it's got a lowest point, and that's the vertex, which we talked about in that projectile motion lesson. But you're going to have a lowest point here, so this is going to be an upward facing parabola. So this is going to be a quadratic function where A is positive. You do not have to find the rules for these. You can if you want to. Feel free to try to do that. It's a good challenge problem, but you're not required to do that. And the reason that I can tell that this is going to be curved is because as these are going up by 1, these are not going up by the same value. So you'll notice we go 4 to 1. That's -3. Well, how do I go from 1 to 0? That's only minus 1. So I'm definitely not a linear equation because I went -3. Here I went, maybe I should not have written that arrow there. Subtracted 1. How do I go from 0 to 1? Well, I add 1 this time. And here I'm adding 3. So you'll notice our signs changed. We subtracted 3, subtracted 1, added 1, added 3. It is not a constant rate of change like it was over here for our linear function where we added 2 every time. So that's how I'm going to know that this is a parabola.